Hello and welcome to another episode of TWIML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. Let me start this show by sending a huge thank you to everyone out there listening. We've dropped a ton of great interviews over the past few weeks, but through your dedication, we continue to see a growing outpouring of feedback, comments, and shares with each release. If you're a regular listener, but don't normally send in feedback, we would absolutely love to hear from you. So please head on over to Apple Podcasts or wherever you listen and leave us a review. Of course, a 5-star review is appreciated, but what's most important is that your voice is heard. It lets us know what you like or what you feel we could improve on, and it lets those looking for a new machine learning and AI podcast know that they should join the TWIML community. Speaking of community, the details of our next TWIML online meetup have been posted. On Tuesday, November 14th at 3 p.m. Pacific Time, we'll be joined by Kevin T., who will be presenting his paper, Active Preference Learning for Personalized Portfolio Construction. If you're already registered for the meetup, you should have received an invitation with all the details. If you've yet to join the meetup, head on over to twimlai.com/meetup to do so. We hope to see you there. Now, as some of you may know, we spent a few days last week in New York City, hosted by our great friends at NYU FutureLabs. About 6 months ago, we covered their inaugural AI Summit, which is an event they hosted to showcase the startups in the first batch of their AI Nexus Lab program, as well as the impressive AI talent in the New York City ecosystem. Well, we were more than excited when we found out they would be having a second summit so soon. This time, we had the pleasure of interviewing the 4 startups of the second AI Nexus Lab batch: Mt Cleverest, Byte.ai, Second Mind, and Bowtie Labs. We also interviewed a bunch of the speakers from the event, and we'll be sharing those discussions over the upcoming weeks. In this first episode of the series, you'll hear from Mt Cleverest, a startup started by childhood friends James Villarrubia and Bernie Prat. Mt Cleverest is an online service for teachers and students that can take any text via the web and generate a quiz along with answers based on the content supplied. To do this, they employ a pretty sophisticated natural language understanding pipeline, which we discuss in this interview. We also touch on the challenges they face in generating correct question answers, how they fine-tune their machine learning models to improve those answers over time, and more. And now, on to the show. All right, everyone. I am here at NYU FutureLabs, meeting with some of the AI Nexus Lab companies. And the first company into the interrogation room is Mt Cleverest. And I'm here with the CEO, James Villarrubia, and the COO, Bernie Prat. Welcome to This Week in Machine Learning and AI.
Thanks for having us.
Yeah, so why don't we get started with an introduction to the two of you, your backgrounds, as well as the company and what the company's up to.
Sure. So my background is really as an engineering statistician. I got an engineering degree from UVA and then a master's in public policy, mostly focused on tech policy. And what I found was the coolest, most interesting problems out there to solve weren't just engineering ones, they were political ones. They were big picture policy stuff. So I jumped into the Pentagon as a statistician and then briefly went to the White House and then finally the DOJ. And then I got kind of tired of DC and got the startup bug and came up to here to New York and helped run a cybersecurity company for a couple of years until eventually this idea that we had about Mt Cleverest finally kind of piqued the right person's interest and they said, go do that. And we said, great, we've been trying to get it going for a long time. So we're really excited.
Thanks, James. And Bernie, how about you?
Sure. So I moved up to New York right after college, and we did some work in a startup in finance where we were pulling data out of press releases to send to programmatic traders. And this allowed me to get into machine learning and natural language processing early on in my career, not as an engineer, but as a manager of engineers doing product work primarily. From there, I bounced around to a few different places, again in product positions, but very, very data heavy, API heavy. And James and I, we've actually been friends for about 25 years. We met in kindergarten.
Oh, wow.
Yeah. And so
it's the first time I've heard that.
Photo evidence, too. It used to be part of our pitch.
Nice.
But we've been friends for a very long time and had always wanted to work together after doing so. We went to high school together as well and did some good work in a number of different areas, but this was the chance for
high
us.
School?
Mm-hmm. Yeah, we were in ROTC together. James was doing the band and the newspaper, and I was a member of that, and we were just all over the place. We had
ones in band camp.
Bernie never went, but we don't talk about that. No.
Nice.
So this is an opportunity for us to work together.
Yeah, finally. Yeah.
Awesome. And so Mt Cleverest, I love the name. It's actually rather clever. I'm sure you never get that. What does the company do?
So we actually started the company kind of based off an idea we had 7 years ago. My parents are both teachers. I actually still teach at UVA part-time cybersecurity. And what we realized is that growing up, I'd see my parents deal with kind of bad textbooks that kind of handed down to them from the administration that they had to kind of bend to meet the needs of the classroom. And we were iterating through ideas, and that was the one that I said, no, like if we could figure out a way to solve this, like this would be really valuable, because my parents just always were complaining about it. So we didn't really quite know the approach yet, and we didn't have necessarily the NLP and machine learning skills to really tackle it yet. But as the industry has grown and kind of our skills have grown, we said, okay, this is something we can apply NLP, machine learning, neural nets, and solve this kind of selection problem. So what Mt Cleverest does is we can take any content on the web, a URL, piece of text, and then generate quiz questions on the fly on that text in a matter of seconds. And then the real advantage, though, is not just creating the questions, but after that, we track every interaction with that quiz, what students get wrong, what they get right, how long they take with each question, what questions and answers teachers like and don't like, what they want to use, feed that into a neural net that then improves the system, improves the quiz for the next person. So it's actually, really at the end of the day, it ends up being one big online textbook that actually improves itself the more you use it.
Interesting. And so I'm familiar with there's a ton of research happening around question answering, which is, you have a body of text, you kind of start with some questions and then you use AI, machine learning to try to answer those questions. You've kind of inverted that and you're using AI to generate the questions as well as the answers and track and adjust over time. Is that as established a research area, the question asking piece?
Not so much. A few years ago, there were very few papers. At least now there is some interesting work being done, but again, nothing substantial because a lot of it has been driven by kind of the question answering Alexa, kind of Siri approach to machine learning. What has been tackled in machine learning is this idea of taking a massive amount of text and figuring out a good question to come around it, kind of the Watson model. Okay, Jeopardy. Being able to parse massive amounts of text and generate one question, maybe a very well-formed question, but it's one question. Our problem, and this really kind of the heart of our tech, is that we take a very limited amount of text and be able to generate 100, 120 questions off of one piece of text, each asking about something different. And then the kind of extra level of difficulty is then, great, you've got a question, you've got an answer that you've drawn out. How do I generate good wrong answers? How do I find a question or an answer that is a good distractor from the correct answer? So I put a multiple choice question in front of a kid. If it's so close to the right answer that it's confusing, that's bad. If it's so far away that they would never guess it anyway, that's also bad. So you got to find the kind of that Goldilocks middle ground on kind of good distractors. And that was really probably the heart of the NLP problem.
I'm imagining like a dial where you can kind of tune the question for difficulty, or I guess a big part of the neural net piece that you described is about kind of normalizing the question answer set so that your kind of average ends up where you want it to be. Is that a good way to think about it?
Yeah, so we can actually look at kind of the readability of the text. There are kind of industry standard scoring mechanisms to take a chunk of text and figure out what grade levels this would be appropriate for. So the origin text, we can actually kind of guess at what these questions are going to come out kind of referring to in terms of like, is this a 5th grade text or is this a 7th grade text? We're actually working on some tech to be able to convert something that is maybe written at a 12th grade level down to a 9th grade level and then kind of use questions that are more appropriate for that. That's kind of in a coming release. But yeah, it's being able to correctly pick questions that are appropriate for a grade level and answers that are appropriate for a grade level is a whole layer of complexity that a lot of other, tech solutions don't really think about, but is unique to the education space.
Okay. I think of educators as folks that kind of want to have a lot of control over their source materials. Like, how does this approach land for them relative to what they're used to?
So we're kind of taking this problem in two different ways. The first is the initial product allows a teacher to bring in whatever content they would like. So if they found a news article that is exciting and relates to their class, or if they have a page that they've been using and sending students to for years, instead of having that all based on paper in terms of the grading, we're actually pulling that in and tracking that information. On the other side, there's a search component that you kind of brought into it. And we're working towards that. That is the broader vision of having a collection, a universe of content, and then being able to rank and sort that. So there's the create problem, and then there's the ranking and sorting. So we've kind of split those intentionally. The control issue, it's something we want to get into. We know that's a political battle in the lightest of terms, because it's not true politics, but yes, that is something that we see often. And so we're coming up with ways to either encourage behavior in a certain way to kind of let go of that, including automatic randomization of questions, or adding in questions from a different source that are applicable to the source that was provided. So we're actually swapping in new information and using that as part of the quiz for students. So it's not a standardization, but it's instead a way for us to help determine the quality of content as well as the student's understanding. And so there's kind of a couple of different problems there.
Okay. There's also a distinction in education between formative assessment and summative assessment. And this idea that teachers get really kind of have close hold on exams because they want to be able to kind of assign really clear grades and hold those students accountable and make sure they can kind of deal with parents that disagree with those grades. They have to have kind of a clear chain. But what has been kind of lost is this idea of this formative assessment, that I want to have homework that a kid can try over and over again until they get it right. Because I'm actually interested in them learning it, not just grading on their first guess. So what Mt Cleverest is really focuses on is kind of trying to get the teacher to not think about the quiz that we are providing as summative, as that you're going to get grades and this is going to count to the report card, but more of a get good questions in front of a kid to make sure that they understand the content and they can take that quiz as many times as possible until they really grasp it or master it.
Okay. Can you talk a little bit about the pipeline that you use to deliver this from a machine learning perspective?
Yeah, so it's it's funny because we get a lot of questions about like, oh, well, can't this just be done by a machine learning model off the shelf? And yes and no, in the sense that we are using some kind of some basic kind of industry tried and true NLP models and neural nets.
What are some of those?
I mean, we are leveraging a lot of NER for name density recognition, using some kind of interesting math around word vectors, what I call like the donut model, saying, okay, I want to find similar words, but then like go up and then remove the words that are really similar to find those kind of, again, the Goldilocks distractors. So those are kind of the approaches that we're doing in the neural nets. We're trying lots of different things because that part of the product is still kind of not nascent, but we're getting there. So we're still kind of refining that. But the pipeline itself, actually, what's interesting about Mt Cleverest is that it's not just one huge, big monolithic model, is that we have to build, an NLP that can generate, dozens of types of questions. So each one has its own kind of pipeline, feeds that into a unified data structure. But then we have to normalize questions against questions, answers against answers, formats against formats. So even within the ranking system, within one lesson, within one subject, we might have a whole series of models. Each, again, not necessarily huge, robust, crazy, big models, but each doing kind of a unique, specific thing.
Can you elaborate on that? What do you mean by normalizing questions against questions? And are we talking about in terms of their difficulty and things like that? Or
right. So in terms of their difficulty, so imagine you're a teacher and you've created a lesson and you want to, we've generated, let's say 100 quiz questions. Now, some of those are not going to be great because the NLP isn't, perfect. No, we don't know many products that are perfect. So we want that kind of human in the loop feedback. So we are capturing kind of what, the upvotes and downvotes, similar to kind of Reddit, of what teachers like and don't like, but at the question and at the answer level. So we get that base level, kind of like how many people have upvoted, how many people have liked or disliked this particular piece. But then we've got this kind of student performance data on the back end. So, okay, well, when I showed this question in this format, in this context, this is how well the student did, given how long they took. So normalizing that data means that I have to take every interaction with every question or format or answer and then trying to figure out, okay, even though this question has been shown to 10 different students in 10 different ways, how do I judge its effectiveness? Is this a good measure of learning on this particular topic? So like that's the normalization that we're talking about.
And is that like some big batch job that runs every X day or week or something? Or is it something that you just kind of trigger periodically? Or
so we've actually made kind of a goal of the product to not do things in batch, which was a bold goal. It may slow us down a little bit, but we set the goal from the user experience level is that we wanted the quiz to improve on a kind of like per interaction basis.
So like every time a kid answers a question,
exactly,
it rejiggers the entire.
Yes.
Does that mean?
So by the time the second student sees the quiz, it's actually improved and changed and learned from the results of the first student.
And is that learning? Does that mean that you are like retraining models and that whole pipeline, or does it mean that are there some set of heuristics that you're using to kind of massage weights or things like that without having to retrain all your models?
A bit of both. So we don't retrain the model every run through, though we do have some kind of tail trained models kind of worked in. But most of it is capturing kind of the heuristics of the performance with those questions in those formats and capturing that and then feeding that back in as additional information into the model as we then kind of randomize and select what we want to do and what we want to show to the second student. So it's the heuristics of the first student fed back into the same model, tail trained a couple pieces, and then kind of what you get, or like, oh, try this version of this content or this version of this question with these answers in this format instead of the old one, because that old version, it wasn't a great test, but this one might be. So it's a little bit of randomization, a little bit of kind of design of experiments, constantly trying to say, okay, how, reduce how many experiments or variations do we need to run before we figure out what the best stuff is.
Okay. And in terms of identifying the target content in the first place, are the educators, feeding URLs into the system to direct you, or are you doing some ML-driven crawling or something like that to figure out the interesting content out there?
At the moment, we're relying on what we consider the expert network of teachers. Okay. So we want the educators to be the one providing content that they have used in the past, and then we'll be doing that ranking in order to help them either bubble up what is better or take advantage of the stuff that they're tried and true sources. So a lot of the open educational resources movement from the Obama administration has been very helpful in that. And a lot of institutions, as well as a lot of individuals are now providing content openly available under a Creative Commons license or the MIT license, whatever it might be, is now available to us and not behind a paywall, not under the umbrella of one of the large publishers or anything like that. So it's taking advantage of that recent trend.
Okay. Interesting. What have been kind of the biggest challenges in pulling this all together?
Well, I think that the biggest challenge was designing that data structure. So again, we have all of these different models all looking at essentially the same data and how you store that in a way that can be kind of lightweight, pulled in the moment, in between quiz questions. That was something that I think both of us had to kind of take a step back and say, okay, how do we store this data at scale, but as kind of, as we're small, but also at scale, kind of building towards this bigger architecture, being able to track what I like to call kind of the context mapping, that it was this version of the question with these answers shown, like maybe there were 10 wrong answers, but we only showed 4, and it was a true false or a multiple choice with a none of the above, not this. So being able to capture all that context and store that and then correctly tease it out and then build a model against it, figuring out what that included and how to put all the pieces of data together. That was interesting. I think we have a model in the tool called a quinstance, which essentially is a quiz instance. Because we've got to generate a quiz, and it might have teacher preferences at one given moment, but then within that quiz, within that context, we need to have an individualized version for each student that they experience at that moment in time. It's like, well, how do we refer to that? It's a quiz, but that's also a quiz. So it's quinstance became our term, and it's been great. But we have a lot of those little things that we had to kind of figure out on the way that we have to structure this and store this in a unique way that I think gives us an advantage in the market that I don't think other people have really thought about data for education this way yet.
And so for folks that are how did you approach that problem? Did you just stumble upon the answer, or did you just try out everything that was out there and see what worked? And what did you end up doing?
These are sore subjects. Be careful here. That's all right, buddy.
Oh, man. Flashbacks. I actually, when we first started trying to build this, I was just like a budding web developer. I actually built the whole tool without a lot of the neural nets. I hadn't quite gotten there yet. But I built my own kind of parsing engine and NLP engine out of PHP. because it was the only language I knew. Right. So I had a lot of lessons learned.
Indeed.
Right. So it was a terrible, terrible idea with I think on the front end was a Drupal 6. It was, right. Exactly.
We're not proud of these moments.
But it was they
were learning experiences.
But exactly. And I got 10 times better as a developer, and it jump-started, I think, a lot of my career just having to suffer through that. So having a really good problem to chew on for a long time. And then eventually I said, okay, well, no, Python is better for this. There's Java libraries that I can start to incorporate. I need to stand up microservices architecture. So right now we have, I think, 14 different microservices, each running even different parts of the models, all talking to each other, leveraging the same data set, caching some parts here and there. So, but I had to learn that kind of all on my own, starting with that poor Drupal site. But yeah, that's is trial and error.
Could have been WordPress.
It almost was. I thought it was advanced when I found Laravel. I was like, ooh, man, it's not Drupal. But
nice.
Yeah.
In terms of the data store, did you is it some kind of document-oriented MongoDB type of thing, or Cassandra, or what direction did you go?
We actually, because we didn't really know what we were doing, and I think that's actually a great use case for Mongo, is that it's a kind of a turnkey solution, and you can kind of drop in whatever you want, and then there are a lot of kind of lightweight ORMs on top of it, so you can change the model, and it doesn't break everything. You just have to go back and kind of clean some stuff later. So we've been doing Mongo for probably the last year as we kind of move to a more production level product. But we've now hit the wall. We're saying, okay, the model types have kind of settled. We kind of know what our structure is. We know what it needs to be. We've thought it out. We've been in the wild and seen what happened. So now we're actually moving to kind of a combination of things. Probably some kind of Mongo or other, NoSQL database for a lot of the document structure, and then probably Cassandra for a lot of the interactions, the in the moment interactions, because its ability to scale kind of linearly, where everyone else kind of stops at a certain point. So yeah, so I'm really excited to move to Cassandra, but Cassandra, also has some, issues around search. You gotta figure out how to get search done. So there's a lot of other, different ways looking at, Postgres for other certain features, because you can index and search there. So we're actually moving to a more complex model, but again, each database has to fit a different part of the system, and we now know how that system really needs to be set up to run at light speed.
Okay. Given that you're doing kind of the interactive updating and all that kind of stuff, I'm assuming that's not still PHP. Is that Spark or?
It is almost there's a little bit of Python on the back end, some Java libraries that I haven't written, but kind of leveraging some open source stuff. But primarily the entire stack is written in JavaScript, leveraging Amazon Lambda and then React as the front end. So we have made this as if the heavens opened up and God said, yes, please, go use this product. And we had massive scale that we are set up to, I assume, handle it. Scale breaks everything. But we knew that there was going to be so much compute that we wanted to make sure we could kind of turn every little lever. So all those microservices, or most of them are speaking, Lambda to each other. And it also means that the models are lightweight enough in some respects that we can offload some of that model computation to the browser. So we have this JavaScript written neural nets. So I can actually load some of the early computation onto the computer for the teacher or the user or the phone, and then do the computation, and then just pass back the results and kind of offload a good 20 to 30% of our load back onto the user. So we're not doing it now, but we are set up to do that eventually.
Oh, wow. And are you using any particular open source library to do the front end inference? Or did you write that yourself?
No, that's a combination of Synaptic. I think synaptic.js was the one we're using right now. And that is, there have been many variations. I think the first one we used was called Brain. There's a lot of JavaScript libraries that are just coming out where they said, I want to write in JavaScript and I want to do neural nets. And they can do some pretty cool things on the browser. Not necessarily the big scale stuff that we want to do on some of our calculations, but a lot of the smaller, within a document, kind of known document space, we can do that on the browser side. And we are going to shift to that model later.
Interesting. And so walk me through, I'm trying to think through the way I've envisioned your process. You get these documents, you're doing a bunch of what I think of as back-end processing to come up with questions and answers and normalize them and all that kind of stuff. What would you want to do on the front end that would require, running the inference locally, or would take advantage of that if not required?
So the first thing you do kind of as a user is you drop in a URL. Eventually it'll be a search term or URL, but right now we're focused on kind of new content capture. So you drop in a URL, and then immediately we go scrape that content from that URL and then start parsing it. And a lot of that parsing work, right now we're handling the back end, but it can be handled by the browser.
Got it.
Right? So that is actually a big portion of the compute because it's a lot of parsing. But if that can be offloaded instead of 10 people doing it all on one of our machines or a series of Lambda functions, but pushing that to the browser, because that's kind of, it's not proprietary stuff, it's not crazy, complicated, but it just needs to get done. Someone needs to pull out, named entities, someone needs to, to do sentence barrier detection. So all that stuff can be handled, and we just want the results, and then we get to kind of the nitty-gritty of the data on the back end.
It strikes me that if a lot of folks aren't doing that now, that's going to be kind of a popular way to do cooperative compute. It's almost like, having your users, mine Bitcoin for you, but more legitimately.
Right. I haven't. The only other industry that I know is really doing that is Bitcoin, and not, my advertising window is mining Bitcoin for someone in the Ukraine. So yeah, but I was like, okay, well, how? When I read that, I was like, that's a really cool architecture, and we'd already been kind of thinking about this. Is so someone's proving that this is doable. So it was kind of a check in the box of, yes, this is maybe where our architecture should go.
Interesting. It strikes me that could be a startup in and of itself.
Right.
Solidifying that architecture, because there's all kinds of problems that you could run into of the process is stealing all the compute and, usability issues and stuff like that.
Yeah, if we figure that out, then we can shift to, maybe that'll be our second business once we sell this one.
Nice. Given all that technology, there's tons of folks, particularly here in New York City, right, doing ed tech. What makes you different?
So we've been doing this project for a long time. So we've been watching the ed tech market when it booms and busts. I think we're on the third boom right now that we've been paying attention to. And we keep seeing investors getting burned, and mostly because they keep investing in kind of this, what seems like a really cool new thing, but in reality it falls into kind of two standard business models. One we call kind of the warehouse model, which is just collect as much information as possible and then make it searchable. But if you look at some of the products out there, you find that the search algorithms are poor at best. And they're not searching on real performance data, just keywords. So you end up getting a big warehouse, and you'll search for the War of 1812, for example. You get 342 results. I'm not speaking about any product particularly. And all of them are ranked 3.9 or 4 stars out of 4 stars. So as a teacher, I tried to use that. I was like, this is useless for me. Great. So am I going to open 342 PDFs and then read them and say, oh, I think this one will work? Right. And even if I learned, this one actually was effective, I have no way to really transfer that knowledge back in and share that with my community. So that was one thing. Okay, we can solve that part. And the other business model is we call kind of the walled garden model, which is more like the 1920s newspaper business model, right? Whereas ed tech companies are essentially taking investor money, paying authors to write content, and then putting it behind a paywall, just like a newspaper, traditional media. And they're saying, oh, no, you can't read it, but I promise you it's the best.
Publisher.
Right. So I was going to say it. So you have this model where the kind of the incentives are misaligned, whereas that it's not in their interest to share what pieces of content they like and don't like, because you kind of get you buy this whole suite of stuff. So yeah, they want to improve it, but they're not necessarily helping the teacher do that and really enlisting the teacher's help, being honest about what is and is not working. And if I ask someone at the New York Times if I think their company or the newspaper is better than the Washington Post, I know who they're going to say, right? I know what that answer is. So getting real data and performance out of kind of this traditional model is just hard. So you've got this kind of high quality, hard to produce, expensive to produce new content model, walled garden, and you got warehouse, which is, high quantity and very low quality. And the more more stuff you get, the worse the user experience gets. So we said, can we tie quality and quantity together? Can we make it kind of a positive feedback loop? And that's really where the AI and the machine learning, kind of cuts in, is that we are capturing at scale enough information to kind of keep floating the best stuff up to the top, but searching through it and capturing it in a way that's not just traditional search. That means we can kind of cut through the top and get quantity and quality at scale.
Have you found that a better way to rank the way you present content is by kind of bubbling up what you've seen with the interactions as opposed to asking for an explicit star rating or things like that? Is that the direction you're going with this?
What I would say is that we know that star rankings are not working. So it's been tried. We are capturing that data, but instead of just having someone vote on I like this piece of content, instead we can capture more interesting data about I've got this piece of content and there's 100 questions in it, and I've seen tons of people who have strong opinions about the top 20. So it kind of, the ranking and sorting algorithm is a bit more kind of off of the Reddit idea of how do you have these kind of layered, nested pieces of information, and how do you float all of that in some kind of, recursive loop of like, oh, now I know that this piece of content is better than this one, and I'm not just using the upvotes and downvotes on those top level pieces, but everything inside. And that's really what's enabled us to kind of take the next level in terms of ranking. And then you combine that with performance data, and now you've got something that, no one else is doing.
Right. Well, that's a very cool story. What's next?
So if you take what we're doing right now and you really tease out that there's teachers using the system, what we can do is we can then take the data that the teachers and students have produced and bring that to institutions themselves and say, here's a view of your school that you've never seen before, one that would benefit you in terms of looking at how your students are actually learning as opposed to just the output grades. Like we're looking at, are the students digging deeper into the content? Are they actually mastering something as opposed to did they just memorize it and move on? So looking at the next phase is using aggregated data of students and teachers at the school level, at the district level, the local government level, that type of thing.
If you remember, we were talking about earlier about the being able to kind of normalize and standardize questions against questions, answers against answers. Well, there's nothing preventing us from using very similar models to rank students against students. And not just students against their classmates or against themselves, but against every other student who's ever touched the system. So what I think is really unique about the way that we're doing this is that even if students see different pieces of content and take different quizzes, we can compare them and say, okay, which student actually learned more, is doing better. And if you look at kind of the way we are standardizing student results today, kind of standardized tests, it's shove a student in a room on a Saturday and you put 300 questions in front of them and pray. And and you hope you get good data. But with Mt Cleverest, though, instead of that 300 questions, you can get 30,000 data points per student per year over the course of a year. And you can finally get to those, as Bernie alluded to, those second order metrics of success that are kind of the holy grails of education policy, of questions like, did the student become more curious? About what did they become more curious? Did the student did they learn how to learn over time? And figuring out kind of where and what was, what they're most successful at. That's the stuff that a lot of kind of the typical standardized test models can't get to. So we know that at scale, that's where we think kind of a lot of this data will be valuable, is that we can actually provide real standardized testing data to schools without them having to actually do any standardized testing. It's just part of the product.
Awesome. Well, James and Bernie, it was great getting to learn a little bit about Mt Cleverest and kind of explore how you pulled it all together. Fascinating story, and really appreciate you taking the time.
Thank you. Yeah.
All right, everyone, that's our show for today. Thanks so much for listening and for your continued feedback and support. For more information on Bernie, James, Mt Cleverest, or any of the topics covered in this episode, head on over to twimlai.com/talk/63. To follow along with the NYU FutureLabs AI Summit series, which will be piping to your favorite podcatcher all week, visit twimlai/nexuslabs2. Of course, you can send along your feedback or questions via Twitter to @twimlai or @SamCharrington, or leave a comment right on the show notes page. Thanks again to NYU FutureLabs for their sponsorship of the show and the series. And of course, thank you once again for listening, and catch you next time.